Okay, strap yourselves in because today we're going deep on some pretty heavy stuff.
Yeah.
False vacuum decay.
Mm,
We're talking about a scenario where the universe could end,
right.
not with a bang, but
Right.
with a quantum bubble.
A bubble.
Yeah, you heard that right.
Mm-hmm.
And you've sent in
Yes.
some amazing articles on this, so
Yeah.
let's unpack this, shall we?
But it's definitely a concept that I think challenges our assumptions about reality itself.
Yeah, the idea that everything we know could be hanging by
Yeah.
a thread woven from, of all things,
Right.
the vacuum of space is a bit unnerving, to say the least.
Well, the vacuum isn't what we typically imagine like empty.
Right.
It's teeming with quantum fields in constant flux.
Right.
And these fields are the bedrock of everything.
Mm-hmm.
Particles, forces, you name it. They even have a baseline energy level,
Right.
known as zero-point energy,
Okay.
which exists even in the absence of matter or radiation.
So even in the supposed nothingness of space, there's a hum of energy.
There-
That's where the idea of a false vacuum comes in. Right.
Oh.
Something about these energy levels not being
Right.
as stable as we'd like to think.
Think of it like this. A true vacuum
Okay.
represents the lowest possible energy state for these fields,
Mm-hmm.
ultimate stability.
Gotcha.
But a false vacuum is like a plateau on an energy landscape.
Right.
It might look stable,
Mm-hmm.
but it has the potential to collapse to a lowered energy state.
Okay. So it's not just that the universe is expanding, it's that
Right.
the very foundation of reality could be on shaky ground.
Yeah.
And what role does the Higgs field play in all this? From the
Mhm.
articles you sent, that seems to be the potential troublemaker.
The Higgs field is crucial because it's what imbues particles with mass.
Right.
No Higgs, no mass, no
Right.
stuff.
Right.
And some measurements suggest it might be in a false vacuum state.
Hold on, that's kind of terrifying.
Yeah.
But the articles also mention something about quantum tunneling.
Mm-hmm.
Does that mean there's a chance this whole collapse could just happen spontaneously?
Quantum tunneling is where things get really weird. It allows particles to essentially tunnel through energy barriers
Right.
that they shouldn't be able to overcome classically.
Like defying the laws of physics?
Kind of. Yeah, it's a bit like a ball suddenly phasing through the wall of a container
Right.
instead of having to roll over the top.
So even if the Higgs field seems stable now, it could just suddenly tunnel to a lower energy state.
In theory,
Yes?
without warning.
Yes. And that's where we get to the bubble of doom scenario.
Okay.
If the Higgs field were to tunnel to a true vacuum state, a bubble of this new reality would form
Mm-hmm.
and expand, rewriting the laws of physics as we know them.
And the kicker.
The kicker is this bubble would expand at the speed of light.
Wow. Okay, so no gentle decline.
No.
Just a sudden and unstoppable wave of change.
Yeah.
What happens? Well, everything inside this bubble.
Yeah.
I mean, the articles describe some pretty wild possibilities.
Inside the bubble, atoms might not even hold together.
Wow.
The fundamental forces of nature could operate differently.
We're potentially talking about a reality where the very building blocks of matter are different.
So everything we know
Yeah.
is essentially
Right.
rewritten.
Yeah, it's a profound concept,
Yeah.
and it really forces us to confront the limitations of our understanding of the universe.
That's an understatement.
Yeah.
If the laws of physics themselves can change, what does that even mean for our concept of reality?
Right.
And what about us? Would we even realize what's happening if this bubble were to engulf us?
It's a question that really pushes us to the very edge of what we can comprehend. Imagine a reality where the rules that we've spent centuries deciphering simply no longer apply.
Right.
Would we even be able to perceive such a shift? It's a mind-boggling thought.
It really is. And I have to ask, where does this whole idea of vacuum decay even come from?
Right?
Is it just a theoretical possibility, or
Yeah.
is there something in our current understanding of physics that suggests it could be a real threat?
It's deeply rooted in quantum field theory and our attempts to understand the energy landscape of the universe.
Mm-hmm.
Remember how we talked about zero-point energy, that baseline energy level of quantum fields?
Right.
Well, think of it as a vast ocean
Okay.
with different depths representing different energy states.
Gotcha.
A true vacuum is the ocean floor,
Okay.
the lowest possible energy. But what if we're on a submerged island,
Right.
thinking we're stable,
Mm-hmm.
while all along there's a deeper abyss waiting?
Right.
That's the essence of a false vacuum.
Oh, so we could be blissfully unaware going about our cosmic business while this potential for a catastrophic drop in energy looms beneath us.
Exactly.
And how does the Higgs field factor into this unsettling metaphor?
The Higgs field, with its unique properties,
Mm-hmm.
is what some physicists suspect might be residing on that precarious island. Its measured mass
Mm-hmm.
seems to place it in a zone of ambiguity, a gray area where it could be in a false vacuum state.
Okay, so there's a chance, however slim, that the very field responsible for giving everything mass could be the trigger for a universe-altering event.
Right.
And to make things even more complex, the articles mention something about the electroweak force being involved.
Mm-hmm.
Can you shed some light on that connection?
You're touching on a fascinating aspect here. In the very early universe,
Okay.
just moments after the Big Bang,
Right.
the electromagnetic and weak forces were actually unified as a single electroweak force.
Okay.
But as the universe cooled and expanded, symmetry broke,
Uh-huh.
and these forces separated.
So a cosmic divorce of epic proportions?
Indeed.
But why does
Huh.
that matter for vacuum decay?
Well, some physicists speculate that this separation of forces might not be entirely stable.
Okay.
What if the Higgs field's potential instability could somehow trigger a reemerging of these forces, essentially rewinding the clock to that early universe state?
Wait, are we talking about a scenario where the laws of physics as we know them are not only rewritten but actually revert to a more primitive form?
It's a possibility.
Yeah.
And it highlights just how interconnected the fundamental forces of the universe truly are.
Wow.
A shift in one could have ripple effects that cascade through the entire system,
Right.
leading to changes we could barely fathom.
I'm starting to see why this topic keeps physicists up at night. But there's another piece of the puzzle that we need to address: dark energy. The articles mention some potential links between dark energy and this whole vacuum energy conundrum. What's the connection there?
You've hit on a key point. We've observed that the expansion of the universe is accelerating.
Right?
And the leading explanation for this is dark energy, a mysterious form of energy that seems to permeate all of space.
Right.
And this is where things get really intriguing. Some theories propose that dark energy itself
Oh.
could be a manifestation of the vacuum energy we've been discussing.
So this invisible force pushing the universe apart could be linked to the very energy that might also hold the potential to tear it all down. That's a pretty wild thought, but if that's the case, why is the observed dark energy so much weaker? Then what our theoretical calculations predict for vacuum energy? That seems like a pretty big discrepancy.
That's the crux of the cosmological constant problem.
Okay.
Our theories suggest that vacuum energy should be incredibly dense, far denser than what we actually observe.
Right.
It's one of the biggest mysteries in modern physics, and it directly ties into the questions surrounding false vacuum decay. Are we missing something fundamental in our understanding of vacuum energy? Or is there some mechanism that suppresses its strength,
Right.
preventing the universe from tearing itself apart?
So we've got this potential time bomb of vacuum energy, but we don't know how or when it might go off, or even if it's actually armed.
Yeah.
And on top of that, we're trying to figure out if it's connected to this enigmatic force driving the universe's expansion. It's a lot to wrap your head around.
It is.
But even with all this uncertainty, I think the articles did hint at some attempts to figure out if we're actually in a false vacuum state. What can you tell us about those efforts?
It's a bit like trying to defuse a bomb, when you don't even know what kind of explosives it contains.
Right.
But that's the challenge and the allure of this whole mystery. Physicists are tackling this problem from several angles, trying to refine our measurements of the Higgs field's properties and looking for any subtle signs that might indicate its stability.
So there's active research going on right now
There is.
to determine if we're actually on the brink of a cosmic collapse. That's both reassuring and terrifying at the same time.
Yeah.
But let's say, for the sake of argument, that we are in a false vacuum and this bubble of true vacuum starts expanding.
Right.
What would that actually look like?
Yeah.
Would we even have time to comprehend what's happening before it's all over?
That's a question that sparks a lot of debate because the bubble would expand at the speed of light.
Right.
It would effectively be instantaneous from our perspective.
Right.
There would be no warning, no gradual shift. One moment, the laws of physics as we know them would apply, and the next, everything would be fundamentally different.
Okay, so no slow motion apocalypse.
Oh.
Just a sudden and dramatic shift in reality. But the articles did mention some dissenting opinions on just how destructive this transition would be.
Right.
Some physicists seem to think it might not be a complete game over scenario.
That's right. Some theories suggest that certain forms of matter or energy might be able to survive the transition,
Okay.
albeit in altered states. It's even been proposed that a new universe could arise within the bubble.
Wow.
with its own set of physical laws and perhaps even new forms of life.
So instead of utter destruction, it could be a cosmic reset, a chance for something new to emerge from the ashes of the old. That's a much more hopeful perspective. But even if some remnants of our universe survive, wouldn't the transition itself be unimaginably chaotic?
Undoubtedly, it would be a period of extreme energy fluctuations and transformations, potentially even more dramatic than the conditions in the very early universe. But within that chaos, there might also be the seeds of something new, something we can't even begin to comprehend with our current understanding.
It's a truly humbling thought, realizing that the universe might have more tricks up its sleeve than we can possibly imagine. But I have to ask, if this bubble expands at the speed of light, wouldn't that violate Einstein's theory of relativity?
hmm
Isn't the speed of light supposed to be the ultimate cosmic speed limit?
That's a common misconception. The speed limit applies to objects within space-time,
Yeah.
not to the fabric of space-time itself.
Okay.
The expansion of the universe, including the propagation of this hypothetical bubble, is a stretching of space-time,
Gotcha.
not a movement through it.
So it's not like a spaceship trying to break the sound barrier.
Right.
It's more like the racetrack itself expanding, carrying everything along with it.
Exactly, and that's why this bubble could theoretically engulf the entire universe, even though it would take billions of years for light from the most distant galaxies to reach us.
Wow, so even the concepts of time and distance get warped in this scenario. It really stretches the limits of our imagination. I think the biggest takeaway for me from all this is the sheer vastness of what we still don't know. We're grappling with concepts that push the boundaries of human comprehension.
Absolutely. The idea of false vacuum decay is both awe-inspiring and unsettling. It forces us to confront the fragility of our existence and the mysteries that still lie hidden within the fabric of reality, but it also ignites our curiosity and drives us to explore further,
Right.
to seek answers to questions we might not have even known to ask before.
It's a reminder that the universe is a far stranger and more wonderful place than we often give it credit for, and who knows what other mind-boggling discoveries await us as we continue to delve deeper into the mysteries of the cosmos.
Well said. Perhaps one day we'll have a clearer picture of the true nature of vacuum energy, the fate of the universe, and our place within this grand cosmic tapestry. But until then, the exploration itself is its own reward.
On that note, I think it's time to wrap up this deep dive. We've covered a lot of ground, explored some truly mind-bending concepts, and hopefully sparked a sense of wonder and curiosity in our listeners.
It's been a pleasure joining you on this journey into the heart of vacuum decay. Until next time, keep questioning, keep exploring, and keep looking up at the stars with a sense of awe and possibility. You never know what cosmic mysteries you might unravel.
And for those of you still pondering the potential end of the universe, remember, even in the face of cosmic uncertainty, there's always the beauty of the present moment. So go out there, embrace the wonder of existence, and don't let the fear of what might be overshadow the incredible reality of what is.